Like terms, this is what we're going to talk about today. You know what? I never liked the term like terms because I remember learning like terms when I was your age or whenever you are right now. I never understood what like terms were because I remember my teacher saying, hey, just find the like terms, collect the like terms, identify the like terms and collect them and combine them, blah, blah, blah. It's always like term this, like term that. And never, if you don't understand what like terms are, I don't know what else you can do to combine them because if you can't identify them, you can't combine them. So it's really important for you to understand like terms. And the term I like to use are more like exact terms, as in exactly sort of identical. Like terms, I guess people just say like terms because they're similar. Let's look at the definition of what like terms are. Like terms, if you look at it, they're terms, as in variables and constants, that contain exactly the same variable, which is like your x and y's and z's and all that, but also with exactly the same exponent. I think that second part is pretty important because I see a lot of mistakes being made when people add x's and x squares together, or y's and y squares, or y3. But like terms or exact terms, whatever you call it, are basically the same variable, same letter, with the same exponent. So let's look at a couple examples down here. Constants, numbers are like terms. It's just like 5 plus 9. Those are like terms when you collect them. So don't even overthink about that. Constants are just, you can just combine them. So here are 4 different pairs of like terms. You can see here 4xy and 3xy. You don't care about the coefficient, the number in front of the letters. You only care about your variable. So this one has x, y beside each other. And do they have the same exponent? Yeah, this one doesn't have any crazy numbers as exponent. This one doesn't either. So these ones are like terms. If you look at this yellow one, 12a squared and 2a squared, this one is a, this one is a. Okay, so that meets number 1, exactly the same variable. Do they have the same exponents? Yeah, they do. So these two are like terms. Do I care about the coefficient, the number in front? I don't. I don't care if it's 12 or 2, if it's negative fraction. As long as these two are like terms, a squared, then I can combine the coefficients. The next two, the orange one, negative 8 and 7, these are constants, so you can just combine them. They're just regular numbers. You don't even have to call them like terms. They're just numbers that you can add together. And lastly, 7f and negative 7f, even though 7s and negatives seems very, very common, like terms are exactly the same variable, which is your f right there. And do they have crazy exponents? No, both of them have the same exponent of 1. So these are your like terms. So why do we need to know the like terms? Because the reason is that when you're adding, subtracting, and combining your polynomials, you can only add and subtract if they're like terms. I just dropped my pen. But you can only add or subtract if they're like terms. And looking at this example, can you identify the different like terms here? I'm just going to go and grab my pen here. I don't even have my pen, but here. Identify the like terms. Let me see if I can draw this out. Here, like term, same variable, same exponent, so x squared. Let's find another x squared. I see this one has a negative, and it's x squared, so it's good. So that's one. What's another one? Let's use a different color. 8y. So what I'm looking for is y to the power of 1. This one has x, y. This one has x. This one is not even a y. This one's a number. So the last one is this one. They're both y's, like terms. Next one, let's use a different color. Let's try green. xy, so we're going to look for xy. This one is only x. This one is a number. So there you go. And lastly, the last one, we can use a blue one. Here's a number, a constant, and here's a number. So I guess the 16x is just kind of left out. So that's your like terms. How do we combine them? So you're going to get a question like this. Simplify by combining or collecting like terms. Basically, here's your question. This is going to be equal to something. And what your answer is basically simplifying, as in you're just taking all the common things and combining them to make it simpler. That's what this question is asking for. The reason why we use algebra tiles is because it allows you to visualize these x squares and x's. So you can, once you get the hang of it, you might not need algebra tiles, but in the beginning it might not be a good idea, might not be a bad idea to use it. So first one, 2x squared. That means I need 2 of these x squares. Remember, each of these ones represent x squares, so I need 2 of them. Negative 3x, that means I need negative. So the color white, the absence of color, that's your 1x or negative 1x. So we need 3 of these, so negative 3x. And the next one is positive x squared. I need a positive with the color, and it's a square, so there you go. And the last one is negative 2x. I'm going to go and put these ones. Again, the purpose of this question of simplifying collecting like terms is to combine these and simplify it into one. So you basically, instead of having like two things, you're just going to simplify it into one. And algebra tiles allows you to kind of move those shapes around and visualize this, because you have 2x squared here, and then you have 1x squared here. So you can see that, hey, you have 3x squares. That's what you did. So the first one is 3x squared. I don't have my pen. I'm just writing this with my fingers, so it might look kind of weird. And then the next 5 different pieces, well, are these positive negatives? Yeah, it's negative because they don't have color. How many of them do you have? 5. And are they x squares or x's? They're x's. So subtract, that's your negative. You have 5, and each of these are x, and that's it. So basically you have broken down this question into this. You just combine everything that looked alike and simplify it. That's the purpose of this polynomial stuff and collecting like terms. So make sure that after you have transferred all this into your shapes, don't forget to simplify and combine them and write out your answer. This shapes is not really completely the answer. You have to rewrite this into this form. Okay. Here's another example. P's. Hey, simplify by collecting like terms like this. P squared subtract 2 subtract 3p squared plus 4. I don't care if it's p's or x's. These shapes still mean the same thing. So p squared. Here's 1. Negative 2. I need the white one, so we need 2 of these. This will make it negative 2. Negative p squared. So I need the white one, and I need 3 of these because each of these, one of them is a p squared, and I need a positive 4. Oh, I see something that's we haven't really done that much of, and that's opposite colors. So once you see this, you can actually find the opposite colors. You can see that they're same shape, opposite colors. And remember, if they're opposite colors, it's like a +1 and a -1. Oh, that's not a +1, that was a 0. So +1 and a -1, they cancel out, so we can just cancel that. Let's look at the ones. This, same thing, so that cancels. And we have one more. These two, they can cancel, so we don't need that anymore. So what are we left with? We have 2 of those big blocks, which means squares, and 2 little blocks means constants. So let's write out the answer. This is your negative x squared, so we have 2 of them, so it'll be negative 2x squared. And each of these red ones are 1, so we have 2 plus 1, so that'd be +2. So that's all it is about collecting like terms. Make sure you understand your algebra tiles. Keep practicing. As long as you practice, this will be easier. So thanks for watching.